The following is a tutorial for some of the basic functions and operations of a program we use with the Flex panel to control a heat pump loop. So this is our home screen, and this is the same home screen that I would be looking at if I were looking at the Flex panel. We have multiple different navigation buttons, and these buttons take us to different screens to show us information and be able to edit different set points and provide different controls to the system. This is an alarm indicator, which when I click on it will bring up the alarm list. Currently there are none. In the event of an alarm, this indicator will change color, and also a buzzer on the door will start to buzz. And I can click on this silence button to silence the buzzing for 1 hour. The first navigation button we'll click on is the help button, which when you click on it will take you to the contact information for the company owners. If you're in need of getting a hold of someone from Gabriel Industries and you don't have their numbers, click on the help button and it will show you. So if we click on the login button, it will take us to the login screen. Now you just saw me log in a little bit earlier, but if I wanted to say access the settings screen, which I'm going to show you next, I wouldn't be able to do that unless I was logged in with an acceptable user security level. So type in my username and my password, and there would be a login button here that I would click on once I've entered in my information, and it would show me that I'm logged in. I am currently logged in as user 0. And I am logged in as a user that has access to all the different functionality of the system, so I'm able to get into more sensitive screens. The Flex panel is an excellent solution for water source heat pump systems, and for this example we've pre-programmed a heat pump loop system. So we're going to click on that now. When the system means to regulate the temperature of the loop, up or down, it will initiate a stage of heating or cooling. If more intervention is necessary to get the temperature into the desired range, a second or third stage or fourth is initiated to achieve this goal. Each system is different, and each stage is going to control a different function that is customized on a case-by-case basis. Typically, these stages will enable a pump or motor or heating or cooling unit via a relay located in the Flex panel. The Flex panel can also provide PID control utilizing variable signal outputs for a more in-depth control over the system. At the top of the screen, you'll see a text field which will show what the current state of the system is. Right now, our temperature is within a satisfied range, so we are neither telling the system to heat or cool. This green line represents the temperature of the heat pump loop, as well as this numeric display tells us what the temperature is. These other lines represent the different stages of heating and cooling. This line is for the first stage of cooling, second, third, fourth, and the first stage of heating and the second stage of heating. To the left we have our flow proving switch showing that we have flow, and the statuses from our lead and lag pumps. Right now it shows that we do have flow and that we're receiving a status back from the pump telling us that it is running normally. So first we're going to demonstrate how the system reacts to changes in loop temperature. So I'm going to drive up the loop temperature a little bit and try to get the system to engage its first stage of cooling. So as we see, it's past the first line here that shows representation of the first stage of cooling. and the system status shows that Cool 1 has energized. You'll notice that the system didn't go into Cool Stage 1 immediately. There is a little bit of an on delay there, and I'll talk about that a little bit later on. So let's say Cool Stage 1 isn't good enough. It's an extremely hot day out. So the temperature goes a little bit higher, and now Cool Stage 2 has energized. And as our temperature goes back to this normal satisfied range, the system goes back to no stages of heating or cooling. And conversely, it works the same way if the loop is getting too cool. Now, if something in the system was not operating successfully, and our temperature went below our preset low alarm set point, the system would give us an alarm. And there it is. At this point, a buzzer is going off, notifying anyone in the area that something is wrong. Our alarm indicator pops up, so we can click on it. Our heat pump loop low temperature alarm has been triggered, and we can acknowledge that. And if I'm hearing that buzzer, I could silence it. Could fix the issue. And by some intervention, the temperature goes back to normal. Next thing we're going to talk about is a safeguard that we have for the pumps. We have a flow proving switch to tell us that the pumps are doing what they're supposed to do. But in the case where we're commanding one of the pumps to come on, but we don't have an indication of flow, we will automatically energize the lagging pump to instead come on and see if that can get the flow switch to close. So I'm going to demonstrate that now by killing the flow, waiting the preset amount of buffer time before the safeguard initiates. There it is. Pump 1 is on, our flow is back on, and we are given a notification alarm. Heat pump loop, lead pump failure. So I acknowledge that. So at this time, I've just acknowledged the alarm, so I've been notified that something is wrong. I can look at our pump 2 to see why that wouldn't be functioning correctly. Once I think I've fixed the issue, can hit our pump reset button to put pump 2 back into action, and our flow seems to be holding, so the issue is resolved. Next we have a trend screen. Unfortunately, this WebMI program is not set to show a trend, but if I were standing in front of the Flex panel, I would see a blue line for the cool set point, and a red line for the heating set point, and then a black line to show a visual representation of the heat loop temperature going in and out of that normal temperature range. So next we'll go into the set points. We can access that screen either from this button or from this button. And first we're going to be looking at the loop set points. So this is the user screen to determine when each of the different stages of heating and cooling should initialize. We have our cool stage 1 coming on at 28 degrees. Right now we're sitting at 25-ish. so there's no reason to bring in any cooling. And we have our heat stage 1 at 22 degrees. And here is our on delay, which I was talking about a little bit earlier. Each stage has an on delay and an off delay. And the purposes of that is so that each stage doesn't turn on and off more frequently than it has to. So in this circumstance, if the loop temperature rises to above 28 degrees Celsius and stays there for 5 seconds, then cooling stage 1 will energize. And then when the loop temperature drops to below 28 degrees Celsius and stays below that mark for 5 seconds, then cooling stage 1 will de-energize. And all these settings are editable from this screen because I have the security access. So if I want to change it, click on the icon, let's change it to 27, hit enter, and now it's at 27. And you'll notice that there are pre-saved set points. So I made an edit earlier to change these to 5 seconds because it was taking a long time for this demonstration. If I were to revert back to the defaults, you'll see that this will turn back to 28 and these will turn to 30. So let's revert back to our default set points. So 30 is more of a real world set point for on delays and off delays. 5 seconds is a little quick and doesn't really serve the intended purpose. But let's say even 30 isn't enough. Let's have our stages of heating and cooling come on when the temperature is right for 45 seconds. You'll notice it's prompted me to revert back, if I wish, to the default or to save a new default. Let's say this new configuration works out well. I'm going to keep this as the norm, so I click on save. Now any change that I make can be easily reverted back to by clicking on the revert to default button. Next we're going to be looking at the loop pump control. This is a familiar visual display. It's the same as what was on the heat pump loop screen. From here we can toggle what the lead pump is and what the lag pump is. Right now pump 2 is leading. Now the schedule is completely flipped so that this week pump 1 is leading and pump 2 is lagging. Also we can override pumps to always be on for the duration that the button is pressed. So let's force pump 2 on. Clearly says override, we're getting status, and if you go back, you'll see that the settings button starts to flash this yellow color, and that's to indicate that there is a setting that may not be desirable or may not be intended for long-term use, which overriding a pump on is certainly not intended for long-term use. Next we have our alarm set points. So our high alarm set point for the temperature loop is 40 degrees Celsius. You can adjust that to 38. If I like it, then I can save it. And we can adjust the low. Say I don't want it to get that low. Or if I do want it to be that low, I can revert back. This shows our alarm log, and I've been clearing the alarms because they are intentional, so there are none to report. Next is our system test screen. And this screen is mostly used for commissioning to simulate when certain stages need to be turned on. These are momentary buttons. You can press and hold and watch to make sure that the respective stages, in fact, operate. And this alarm test button can be clicked to test an alarm notification. An option with the Flex panel is an email notification, so that in the event of an alarm, the Flex panel will send a pre-scripted email to the user to notify them that there is an alarm and what the nature of that alarm is. And you can click on this button to test that email generation. On the Flex panel, there's a PLC on the door, and the PLC has a couple different soft keys. One of them is the system button, and you can use the system button to change the time. If you're data logging, you'll want the timestamp to be accurate, but other than that, the system key is not something that needs to be accessed very often and actually contains some sensitive communication configuration settings that need not be edited. So we have this enable and disable button to keep those menus from the hands of unauthorized individuals.